So we're at the bottom right corner of the first page. When you apply a square root when solving an equation, you must put a plus or minus symbol on your answer. So let's solve this first one the way we know how to, which would be factoring and then using the zero product property. Now, what do I mean by this? Now, let's set it equal to 0 by subtracting 9 and subtracting 9, okay? Now, I'm going to have x squared minus 9 equals 0. And then I think, okay, if I do have this equal to 0, that means if I could set this up as something times something equals 0, then I could use a zero product property to split it, yeah? So I want to use factoring here. So let's go back and think, what times what is the c value that if I combine together gives me the b value? Now, what is the b value? 0. There is no b value. So in other words, what times what is negative 9 that if I add together is nothing? That'd be a negative 3 times a positive 3. You guys remember that? Factoring? Yeah? If we just factored this right here, x squared minus 9, that would break down to this parenthesis situation, x minus 3x plus 3. I hope everybody agrees with that. We've been factoring for a while. So now, why would I factor it? So I could split it and solve. So now I really will have x minus 3 equals 0 and x plus 3 equals 0, which means that my answers are going to be x equals 3 and over here x equals negative 3. You guys all agree with that, right? Now, the quicker way of doing this problem, let me rewrite it right here. X squared equals 9. The quicker way is to think this. I want to get x by itself. This x is almost by itself. I just have a little square up here. I don't want this little square. I just want the x by itself. How do you get rid of something? You do the opposite. What is the opposite of a square? A square root. So apply a square root, and what you do to one side, you must do to the other, and you will get x, because we know that the square root of x squared is just x. It's kind of like the square and the square root undo themselves. It's kind of like having an x plus 3 and then doing a minus 3. It'll get rid of the plus 3. So you do the opposite of a square, which is a square root, and now you just have a beautiful x. X equals, now we know that the square root of 9 is 3, but we have to put a plus minus right in front of it. That's the rule. When you apply a square root in an equation, you have to put a plus minus right in front of your answer. Now, we could clearly see it down here when we're factoring and splitting and solving. We actually get a positive 3 and a negative 3. But up here, when we look at it in the original equation, we need to remember that rule that when you apply a square root, you have to put a plus minus in front of your answer. So moving on. Or not. Yes, moving on. So let's go with the using roots to be able to solve the answer here. Instead of factoring, splitting, and solving, let's get x by itself. Okay? So I am going to do what on number 2? First thing to do. Add 16 on both sides. That's what I would do, right? Add 16. You're going to end up with 4x squared equals what? 36. Hey, that's a perfect square number. But, okay, let's keep going here. Let's get rid of the 4. How do I do that? Divide by 4. Divide by 4. I end up with x squared equals 9. And that's a great situation because when I apply a square root and I apply a square root, I'll get x equals plus or minus 3. Now, I know some of us are going to write 3 as an answer, and I'm sorry, I only could give you half credit because that's only one of the 2 answers. If you just write 3, you're only giving me one of the 2 answers. You have to write plus or minus 3, okay? So make sure you put that plus minus right in front of there. Moving on to number 3 here. What do I do first? Okay, you can't even, now, distributing is multiplication, right? Exponents come first before multiplication. So if you wanted to simplify, you would have to actually get x minus 3, write x minus 3 times x minus 3, do FOIL, and then distribute the 5 into your answer. That's a lot of work. Why not just start isolating your squared term by dividing by 5? Now you could go that first route that you guys just mentioned, But let's start dividing by 5 on both sides. That way the 5 cancels out. You'll have an x minus 3 left over squared equals what? Equals 4. And now at this point, let's say that we wanted to get rid of that square on that binomial x minus 3. How can I get rid of a square? By doing the opposite of a square. What's that? Square root. So we're going to square root that side, square root this side. Now keep in mind, the rule says whenever you apply a square root, what do you need to put in front of your answer? Plus or minus. So on the left side, I really do just have an x minus 3. But on the right side, I now have a plus or minus 2. Okay? What's my final step to solve this? Add 3 here, add 3 over here. Now, let me rewrite this. This canceled. X equals, now this is what I have. I have 3 plus or minus 2. I can't actually do it. The answer is not plus or minus 5. I can't actually add 3 plus 2 and then just slap a plus or minus in front of it. Because the plus or minus belongs to the 2. So I really have 3 plus or minus 2. Now that actually means something. That means 3 plus 2. And it also means 3 minus 2. Which will give you 2 totally different answers. So 3 plus 2 is what? 5. That is one answer. 3 minus 2 is what? 1. That's another answer. Cool?
Kind of confused.
Kind of confused?
Yeah.
Let me pause it. So, for the sake of time, we're going to just flip the paper over and move on to complex numbers. So, section 4.4, this is the actual real part of 4.4. Everything that we did on the other side was just a review to better understand this next section. So right here it says that we're going to be performing operations with complex numbers. Before we even discuss what a complex number is, let's talk about square roots. Now you guys all know that the square root of 9 equals 3. Why? Because 3 squared is 9. But what if I asked you what's the square root of negative 9? Right? Well, the answer is not positive 3. The answer is not negative 3. You need to think of a number that when you square it will give you a negative 9. And you can't really find that number. It's not a real number. 3 squared is 9. Negative 3 squared is positive 9. So the square root of negative 9 is not a real answer. It's an imaginary answer. In this case, 3i. Okay, so let's talk about the truth about I, which is an imaginary number. What is I? Let me tell you this. The square root of negative 1 is I. The square root of a negative is imaginary. Okay? So this is a fact right here. The square root of negative 1 is I. Another fact, very important fact, is that I squared is negative 1. I squared is negative 1. Okay? So these are just facts that we need to know. And you know what? I'm not even going to try to... Okay, I'll confuse you. Why not? So like let's say you had I times the square root of a number squared. You'd have to write this twice and have I times the square root of that number times I times the square root of that number. So here it is. I times the square root of that number times I times the square root of that same number. So if you rearrange things, put this I together with this I right there, right next to each other. Put this square root together with this square root. Like if this were the square root of 3 with the square root of 3, put them right next to each other. Then you'd end up with I times I, which is I squared, and then the square root of the number times the square root of the number, which would be the square root of the number squared. Now we all know that the square and the square root will eliminate themselves, so you'll just have the number. And we all know that the fact says up here that I squared is negative 1. So you have negative 1 times that number, which is just the negative number. Fun, huh? Okay, sorry, let's move on. Let's try to really understand I. So I is, where does it come from? It comes from the square root of negative 1. I is I. I squared, we said, was negative 1. What's I to the third? It's actually negative I. Now let me explain why. It kind of rhymes. I to the third could be rewritten as I squared times I. Isn't that right? Now what is I squared? I squared is really negative 1 And what about this other I that's left over? Let's just put it over here. So what's negative 1 times I? It's just negative I. So I to the third is really just negative I. Are you with me? What's I to the fourth? I'm going to rewrite this I to the fourth as I squared times I squared. What's I squared? That's really a negative 1 times a negative 1. What's my final answer for I to the fourth? 1. It's all going to boil down to this, guys. You need to know this fact. I squared equals negative 1. Anytime you have I squared, you have to replace it with negative 1. Okay? So notice right here, I have I to the third. Well, that's really just I squared times I, and we know that I squared is negative 1, so my final answer is negative I. There it is, negative I. What's I to the fourth? Oh, that's really could be rewritten as I squared times I squared. That's really negative 1 times negative 1, which is positive 1. You guys got it? How about I to the fifth? I to the fifth. Negative 1? What did we just say that I to the fourth was? It'd just be I. The final answer would just be I. Why? Because we said I to the fourth. What did we just say I to the fourth was? It was 1, right? So I could rewrite I to the fifth as I to the fourth times I. That's I to the fifth. And I to the fourth, we just said that this guy was really just 1. So you really have 1 times I, which is just I. Does that make sense? Or you didn't have to think of it as I to the fourth times I. You could have thought of it as I squared times I squared times I. And this is negative 1 times negative 1. That's positive 1 times I. That's just going to give you an I, right? The key is that I squared is negative 1. I squared is negative 1. Okay, so you could use the fact that I to the fourth is 1, right? We just said over here that I to the fourth is 1. So you could use that fact on this next one, number 2, I to the eighth. What's that really going to be? It's going to be I to the fourth times I to the fourth. So that's really 1 times 1, so your final answer is 1. So I to the eighth is really just 1. So it's a question of manipulating with exponents. I to the sixth. Let's rewrite that. What do you know? What's the fact that I'm asking you to memorize? I squared is what? I squared is negative 1. So let's rewrite I to the sixth in terms of I squared. Well, let me say I squared times I squared times I squared. Because that's really I to the sixth, right? So what's my final answer going to be? It's going to be negative 1. How about I to the 10th?
Why wouldn't we just do I?
You could do I fourth. Going back to 3. Let's go I fourth times I squared. We said I fourth was what? 1, and I squared is what? Negative 1. So you have 1 times negative 1. Hey, it's negative 1.
If you did it with I in the third power, it wouldn't.
Okay, say what? I to the 10th, you could rewrite it however you want. You could say I squared times I squared times I squared. Write it out 5 times, right? Or you could say that you're going to rewrite it as I to the fourth times I to the fourth times I squared. So we know I to the fourth is 1, I to the fourth is 1, I squared is negative 1, so the final answer is negative 1. So whenever you just have i's to a certain power, it's either going to be I, negative I, 1, or negative 1. That's the bottom line.
I thought it was 5 I squared.
You could do I squared 5 times. And if you did go I squared times I squared times I squared 5 times, it's really a negative 1 times negative 1 times negative 1 5 times, which would ultimately give you a negative 1 as an answer.
Okay, that's
Let's pick it up here on the next video.